All right, number 5, we have a new symbol introduced. It's an arrowhead. It is read implies. It is also read if, then. So if you do this, then I will do this. Okay, the truth condition for a statement with implies involved in it is only going to be false. So this is false if the first part is true and the second part is false. Okay, so if we have true then false, this statement will be false, containing implies. Everything else will be true. Here's an example. Let's say if you make all A's, then I will give you, let's just say $100. So I got a kid. I tell my kid, if you make all A's, then I will give you $100. Okay? So if he makes all A's, but I do not give them $100, then this is a false statement. I have lied. Okay? All other cases will be true. Okay, so let me show you. If he makes all A's and I give him the 100, then that's a true statement. If he doesn't make all A's, I may still be lenient and I can still give him $100. That's still a true statement. I haven't done anything false. If he doesn't make all A's and I don't give the $100, that's true. Because condition says you have to do this in order for me to do that. So if you meet your part and I don't do mine, it's false. Everything else will be true. Okay? Because if you don't, then I don't. If you don't, I still can, and nothing's wrong. And if you do, then I do. So only false if you have true and then false with implies. Okay, so now we can fill in this table. Now we have 3 parts. We're going to fill in the table. We're going to answer some questions, and then we're going to use part B, whatever we do in part B, to do logically equivalent statements with this mathematical statement given. Okay, so we have true. I'm just going to go across the row. We have true for P, true for Q, implies, that means true. It's only false if I have true, false. Negate P, so if P is true and I do not P, that means false. And then if I have not P or Q, so not P or Q, so this is the 4th one and the 2nd one, I have false or true. Remember, or is only false if they're both false, and they're not, so this is true. All right, then going across this column, P implies Q. We have true and then false. That is the statement that we just talked about, so that means it is false. That's the only one that's going to give us false with implies. Negate P, which means it's true. We're going to negate it. It's going to be false. And then we have or. So if I have false or false, that definitely means false. So when we have or both false, it's false. All right, so now we have an extended table. We're going to do a little bit more. So with the implies, so we're looking at these two. Remember, only false if we have true, false. And both of these are not in that setup. So these are all the scenarios that they're showing you right here. This is the only one that's false. Everything else is true. All right, we're going to negate P. It's false in both cases here, so it's going to be true. Opposite statement. And then we're going to be looking at 2 and 4, these 2 columns. So with or, only false if they're both false, and they're not, so both true here. Okay, part B, we want to know which two statements are logically equivalent. Logically equivalent mean they have the same truth value all the way down the table. So let's start out with P. Since they have P first, does this P row match with anything else? So true, true, false, false. Not. So P doesn't match with anything. Okay, so let's look at not P or Q. So that would be this column. So I'm looking for true, false, true, true. Okay, so it matches with the implies. So 5 and 3 match. So this one matches this one. Okay, so we're going to use what we got in part B. So part B, we saw that these two columns were the same. These are equal. And now we want to know which of the following is an implication of this statement. So we have or. This one says or. So I'm wanting to match from this table my or statement to something that says implies or if then. Okay. And notice it has a not. So also this statement says not equal. So this is almost exactly my or statement with the not in front needs to match up. So what I'm going to be looking for is I'm going to get rid of the not. So I'm comparing this to this. It says not P, so this is going to be true. So I want to say 2 plus 3 equals 5. I'm going to get rid of that not part. So 2 plus 3 equals 5. If that, then this is going to stay the same. So notice Q is the same. It doesn't change values. P is the only one that changes. So I want to go from not true to something that is true and keep the second part the same. Okay, so which one of those says that? So I'm looking for if 2 plus 3 equals 5, then 4 plus 6 equals 10. If 2, okay, so here we go. If 2 plus 3 equals 5, then 4 plus 6 equals 10. This is the one that matches what we did in B, saying that they're the same.